In this video, we'll be discussing the top 3 rules that you'll be using for taking derivatives in calculus and engineering classes. And those are the power rule, the product rule, and the quotient rule. The power rule states that whenever you're taking the derivative of a function with respect to its variable x, and that x is raised to some power n, then the solution is n times x to the n minus 1. So this n comes out front, we leave the x, and we subtract 1 from the exponent. So let's do an example. So say we have some function x squared. The derivative of that function with respect to x is going to be equal to 2 times x to the 2 minus 1, or 2x, since 2 minus 1 is 0. Let's try another example. Let's say y is equal to 3z to the 7th minus 7z cubed plus 21z squared. And we are asked to find dy dz. It's going to be equal to, we just go term by term, applying the same process as we did before, one at a time. So this is going to be equal to 7, bringing the exponent out front. Keep the base the same, even if it has a coefficient already. And then we subtract 1 from the exponent. Minus 3 for the next term is the exponent, times 7z, and then subtract 1 from the exponent. I'm just going to rewrite down here. On our last term, we bring the exponent out front, 2 times 21z times 2 minus 1. If we rewrote this, we would have 21z to the 6th minus 21z squared plus 42z. Z is just a first power. Let's try one more unique example. Say we have a function r. R is a function of theta. All right, now whenever I see a problem like this, I like to recognize that we can rewrite this function in terms of the inverses of theta. So whenever you bring you can make this in this form by doing an inverse exponent. So this is equal to 12 theta to the negative 1 plus 4 theta to the negative 3 minus 1 theta to the negative 4. Whenever you can rewrite a fraction term such as 12 divided by theta as 12 times theta to the negative 1. And now each term is in a form where we can use the power rule. So dr d theta is going to be equal to negative 1 times 12 theta to the negative 1 minus 1 plus, we bring the negative 3 out front, 4 theta to the negative 3 minus 1. For our third term, we have a minus 1 going to bring the negative 4 out front. Theta to the negative 4 minus 1. So this is going to be equal to negative 12 theta to the negative 2 minus 12. See, we are on our second term now. So we're adding this negative 3. So really that's the same thing as just subtracting a negative. And then we're multiplying by 4. So minus 3 times 4, negative 12. And that's multiplied by theta to the negative 4. Negative 3 minus 1 is 4. And then our last term is going to be plus 4 times theta to the negative 5. We're subtracting a negative. Same thing as adding a positive. So that's it for this example. Now we're going to move on to the next rule, the product rule. The product rule states that when you take the derivative of two functions of x that are multiplied together, it's the derivative of the first times the second plus the first times the derivative of the second. Say that again. Derivative of the first times the second plus the first times the derivative of the second. That is the power rule. You can also rewrite these larger terms as a prime term. So u prime v plus uv prime. So let's try an example. So let's say we have y equals x plus 1 on x times x minus 1 on x plus 1. So in this example, this term is going to be our u, and this term is going to be our v. So what I'm going to do is calculate each of the derivatives and then put it all together. So du dv, or sorry, du dx. Yeah, I just realized I wrote this term wrong here. This should be dx. That makes sense because u is not a function of v, so taking the derivative with respect to v wouldn't be proper in the context we're talking about. So du dx is equal to, I'll keep the color white, the derivative of x plus 1 on x. This is also equal to the derivative of x plus x to the minus 1, right? Just like that last product rule example we used. So this is going to be equal to 1 times one plus negative 1 times x to the negative 1 minus 1 equals 1 minus x to the minus 2, or 1 minus 1 on x squared. All right, so I'm going to make some room here. Move this over. Now let's take the second derivative that we're interested in, which is going to be dv dx. dv dx equals the derivative of this expression. This is v. So x minus 1 on x plus 1. Now I'm going to do a little shortcut. So since we're going term by term here, using the product rule, or the power rule rather, recognize that this expression here, these two terms, is effectively the same here, except that the plus in the first term is a minus in the second term. I'm calling each expression a term here. So all we have to do is change the sign in the derivative that we already found to get our solution for the derivative of these terms. Okay, so, and lastly, since all we have to do here, whenever we're taking the derivative of these terms, is just change the sign in this expression here, turn that into a positive. And then we have an additional term at the end here. The derivative of a constant is just going to be equal to 0. So this derivative is just going to be 1 plus 1 divided by x squared. All right. Gonna make some room here. Organize things a little bit. So now we can rewrite our answer. D dx of uv is equal to the derivative of the first, du dx, 1 minus 1 on x squared, times the second, v. Remember, this is v. Plus the first, u. Times the derivative of the second, which is 1 plus 1 on x squared. And that's how you can use the product rule. And lastly, we have the quotient rule, which states that the derivative of a division of functions of x is going to be low, this is how I remember it, low derivative high minus high derivative low, square the bottom and away you go. I'll say that again. And I'll say low d high minus high d low. This is high and this is low. Square the bottom and away you go. One more time. Low d high minus high d low, square the bottom and away you go. Hopefully that mnemonic of sorts will help you remember the quotient rule. So let's try an example. So let's say y equals 2x plus 5 divided by 3x minus 2. Okay, so dy dx. It's going to be equal to low 3x minus 2 times d high, the derivative of 2x plus 5 is just going to be equal to 2 minus high 2x plus 5 d low, derivative of the denominator, just going to be equal to 3 but we have to square the bottom before we can go. So 3x minus 2 squared. If we simplify this, we get, let's see, 6x minus 4 minus 3x plus 15 all over 3x minus 2 squared. This is equal to 3x minus 4 minus 15 is minus 19 all over 3x minus 2 squared. And I think that's simplified pretty nicely. So that's it for this video. Please be sure to like, share, and subscribe if you found this content helpful and want to see more content like this. Your feedback will let me know if I need to continue doing more videos like this. Thank you for watching and have a great day.